Dear Class 7, today we start with a new lesson, Motion and Time, which is lesson number 13 of your science textbook. We have two parts of this lesson. In part 1, today we'll be learning about measurement and the simple pendulum. Okay, so we'll be learning about measurement and the simple pendulum. Right. We learned in 6th standard, isn't it? What is measurement? What do you understand by the term measurement? So, measurement is nothing but a comparison of an unknown quantity with some fixed quantity of the same kind. Okay. For example, you go to the cloth shop and you require a piece of cloth, say 1 meter of cloth. So, what does the shopkeeper do? He takes the cloth, which is the unknown quantity, and then he takes out a meter scale and he then measures this unknown cloth using the help of the meter scale and then cuts 1 meter of the cloth. So, this is measurement. Similarly, we do measurements in a grocery shop. Okay, you take, suppose your mother asked you to buy 1 kilos of potato. So the shopkeeper puts a stone or the 1 kilogram worth of weight in one of the pans, and in the other pan he keeps on adding potatoes till the pans get balanced and you have got 1 kilo of potato. So this is what is measurement. So what are the things that we use for measuring, or the instruments which are used for measuring? Let's begin from your left. The first instrument that you see is a thermometer, isn't it? So these days we are not using thermometers. Instead, we are using the thermal scans or the thermal guns, isn't it, to measure our body temperature. The second instrument that you see is a measuring cylinder, which is used to measure capacity or liquids. The next three instruments that you see are all either a spring balance, a beam balance, or weighing machines. All these are used to measure mass. And the last one right on top, the black one, is a clock, which is used to measure time. So these are the various instruments that you use to measure different things. So what are the units of measurement? Whenever you have measured something, you always express it as a unit of a predetermined um, length or mass, something, isn't it? So this is what is called a unit. So earlier when we went to the cloth shop, when I say 1, does 1 signify anything? No. When I say 1 meter, 1 centimeter, 10 centimeter, then only you will know exactly what it is. So, whenever we do measurements, we always express it as the multiples of some known units or standard units, which we call it as the SI units. So, what are the SI units of measurement of length? It is meters. For mass, it is kilograms. For time, it is second. And for temperature, it is Kelvin. So these are the SI units of measurement. Measurement of time. So how have we started the measurement of time? So we are talking about a period when there were no clocks. So, how did people measure time then? People measure time depending on an event which occurred regularly at regular intervals of time. This helped them to measure time. So, what are these things which occur at regular intervals of time? There are certain events like the rotation of the earth, the revolution of the earth, the revolution of the moon. So these are events which used to happen at regular intervals of time, and man used these to measure time in ancient times. Let us now take a look at some pictures of ancient clocks. On your left, you see a sundial. So, a sundial was a clock which used the shadow formed by the light of the sun. So, you can see a round instrument there, and right there in the middle, you see a slanted stick. So, wherever the shadow falls, that indicates the time of the day. Okay, but the big problem was with these sundials was that if there was no sun, suppose it's a cloudy day, it's a rainy day, or at night, these sundials were of no use then. The next clock that you see on your right hand side is an Egyptian water clock. So these were actually, they did not tell you the time of the day, but they could tell you how much time had passed. 1 hour, 2 hour, 3 hour, depending on the clock. They could only tell you how much time has passed, but it could not tell you the time of the day. So, some more ancient clocks. On the left side, you find a big sundial. Okay, that actually is a whole building, and that is the sundial present at the Jantar Mantar. So one Jantar Mantar is there in New Delhi, the other one we can see in Jaipur. So I think it is one of these. So you can see one big arch is there, and right in the center you have a tower. So this is a huge sundial, and the center tower's shadow falls on either side of this arc. So on this arc are markings of the time of the day. So in this particular picture, you can see the shadow falling on the right hand side. So it is probably just after the midday. Okay, so around between 1 to 2 o'clock. So in the morning, you will have shadow falling on the left hand side, and in the afternoon, you will have shadows falling on the right hand side. The next picture again shows a sun clock. So these were designed again to tell you the amount of time which has passed and not the time of the day. Okay, one more ancient clock was there which actually is a big sundial, and it's part of a temple, is the Konark's Sun Temple. So it's a beautiful temple in the state of Orissa, built on the coast of Orissa in a place called Konark. It's a huge temple in the form of a chariot, and these chariots have 12 huge wheels, and each of these wheels acts as a sundial. Okay, each of it acts as a sundial to tell you the exact time of the day. Next comes the next generation of clocks. So, have you seen this pendulum type of clocks? Huge clocks, probably in your grandparents' house or old houses, in museums or in villages. You might have seen. So, the picture on your left is that of a famous scientist called as Galileo Galilei. He has been credited with the invention of lot of things like the telescope and the pendulum. So, what Galileo did was, one day he was attending church, and in those times the light only had to come through candles because there was no electricity. So, in the church he saw huge candles attached to wires hanging down from the ceiling or the walls of the church, and one had been lit and it was swinging. So, what Galileo did was, he measured his pulse and then found that the the candle actually takes the same time to complete to and fro motion or oscillation. That gave him the idea of a pendulum, and that's how the world's first pendulum clock was built. Okay, so on the right you can see a very old pendulum clock, perhaps not the world's first pendulum clock, but a very old pendulum clock. So these were the first modern clocks that humans built. Now we have very advanced type of clocks. On your left you see a digital clock. Okay, the ones which you wear on your hands, which has got numbers 1 2 3 and the needle moves. Those type of clocks are called as analog clocks, and these are the digital clocks. The one that you see on your screen on the left hand side is a digital clock. On the right hand side, on the other hand, is the most advanced clock, which is the atomic clock. They're so accurate that they do not even lag for a few seconds, even in thousands of years. Okay, so these are kept in laboratories. There are very few in number, and they're very costly clocks. And these are one of the most accurate clocks. Now let us learn a little bit more about the pendulum, or the simple pendulum, which our friend Mr. Galileo discovered. Okay, so what are the parts of the pendulum? The picture on your left shows a pendulum. Okay, so there are only two main parts of the pendulum. Can you see below? A, it is called a bob. It is generally a metal ball. Okay, a metal ball with a small hook. Why is there a hook? For you to attach a string very easily. So a pendulum, a simple pendulum, is nothing but a metal bob attached to a thread. Now this thread has to be fixed to a support. Okay, so we have different we can have different lengths of the thread, and at the end of the thread you have a metal ball. So how is the movement of the pendulum? Okay, when the pendulum is not moving, it is supposed to be at rest or in its mean position. So when you want this pendulum to move, you catch hold of the metal bob, you lift it a little to one side, either it could be the left or it could be the right, and then you leave it. So what happens? The pendulum will come to its middle position, the resting position. Does it stop there? No, it goes all the way to the other side, and then it comes back to the middle position, and then again back to where we had started. Okay, so this to and fro motion of the pendulum is called an oscillation. It's called an oscillation. So one complete oscillation is once the pendulum leaves its position, goes to the other side, and then comes back to its original position, then the pendulum is supposed to have completed one complete oscillation. So, can we measure the time taken for one oscillation? Yes, we can measure, but it is little difficult because it is very less time. So what we do instead, we count some say 20 oscillations, and then we can measure the time taken for this. Okay, so complete oscillation, the to and fro motion of the pendulum about a fixed point, is called as oscillation. Can you see in the picture the pendulum moving from position A to B to C and back to A is called as one complete oscillation. Now here is a small quantity that we need to know, the time period. What is the time period? The time period of a simple pendulum is the time taken for the pendulum to complete one oscillation. So as I told you earlier, how do we calculate it? we let the pendulum complete say 15 to 20 oscillations. Okay, we let it complete say 20 oscillations and then measure the time taken for this 20 oscillations. And what is the formula? Time period is equals to the total time taken divided by the number of oscillations. And what is the unit? It is generally written in seconds. So this is the time period of a simple pendulum. Here's a small activity that you have to do. You have to make a simple pendulum, and if a metal ball is not available to you, you can use a heavy rubber ball also. Okay, or you can make your own heavy balls, and you have to make a simple pendulum and then measure the time period of this simple pendulum. Okay, you can make a small video of it and upload it to my number. So this is the simple activity that you have to do for this lesson. Okay, the next part of this lesson will continue in video number